Hello everyone, welcome back to Enginuity Lab. This is part 39 of our CATIA V5 beginner series tutorial. Today we shall learn one of the most important modeling concept, the multi-body design and Boolean operation. This topic is essential for creating complex mechanical parts, molds, castings and design alternatives efficiently. So let's go to the CATIA, go to start and mechanical design, part design. Rename this one as multibody and Boolean operation. Click on OK. Now we are into the part design workbench. So let's know about multibody concept. What is multibody concept? In CATIA, multibody model means creating multiple bodies inside a single part file. Like here, we are a single part file. We can create number of bodies inside this part file. How we can insert? Go to insert body, then you can find another body is created here. Like that you can create number of bodies in a single part file. The multi-body methods allows you to organize discrete area of geometry within a complex model into different bodies. Like here, we need to create this one. For that, we divided the whole area into 4 different areas or body. 4 different body. In CATIA, by default, the first body is created. It is the part body. Whenever you open a CATIA file, CATIA part file, you will find the part body is the first body. It is already created in the part design. Each geometry area is created in a single separated body. Like here, the outer shape or the outer geometry area is created on part body, and the inside the whole cutout is created on the body 2. These cutouts are created on the body 3, and the holes or the bolt holes are created on the body 4. And then the bodies combined using Boolean operation to create completed model like this. These are the created separated bodies created in a CATIA file. Then we combine all these bodies into in Boolean operation to create the final result of the design. How you can use the multi-body method? First one, break the model into bodies. Like here, we need to create this one, so we need to break the model into different bodies. These can be functional areas, for example complex cutout, or area of the model. Like the body, this should maybe the functional area, like the outer one, then the inner one, then these cutouts, then the bolt holes. Try to combine features that can similar design intent in the same body. Like here, these 6 cutouts are combined together because these all have the same design intent, as well as the holes are also, this is created as pins, the same design intent, so we combine all these into a single body. Define the body structure. In second, we can define the body structure. How we can define the body structure? Click insert, go and click in insert, then click on body to add a new body to the model. Body should be descriptively named so that the design intent is clear. this is always recommended that you should rename the body differently so that the design intent is clear, and whenever you want to edit that body, it is simple for you. How to insert features into the bodies? In third step, you can insert the features into the bodies. For that, what you will do, to activate a body, select it from the specification tree. From the specification tree, you can select a body, then right click, and in the context menu, you can find the define in work object. When you select the define in work object, then the body is activated and it will allows you to work on that body or insert features into that body. At the last, the fourth step, combine these bodies using Boolean operation. What are the advantages? Provides an organized approach to modeling complex parts. Solid features within a body can be hidden independently of the rest of the model. Groups of geometry can be deactivated by deactivating the body. Some group of geometry like this one, you can deactivate, or like, let's open that file. You can insert a feature inside a body by right clicking here, then define in work object. Then you can able to insert a body into this. If you want to hide some features from a body, then you can hide the same, like the holes you want to hide. You can just right click body and deactivate or hide it. Then you can easily hide all the features that are inside the body independently. Group of geometry can be deactivated or activated by the body. Complex geometry is easier to create within a focused area of the model, and your model will be updated faster due to organized structure. Disadvantages. There are some disadvantages also in multi-body method. The number of operations in a multi-body method is greater than the number of operations in a pure feature model method. Here you can find there are number of operations you create are more than the number of operations you can create in the pure body. Like if pure feature method modeling method, then we can create the outer and the inside feature in a single shaft only. But here we have to create two different shafts in body 2 and body part body. Same way the others as well, the pad features, the circular pattern feature, everything is creates multiple numbers of operation in a single body to create this part. Till now we know the multi-body concept. Now we will go to Boolean operations, and we will combine these bodies, different bodies, in Boolean using Boolean operation to create the final output. Before that, we will know about different types of Boolean operations. There, CATIA provides 6 Boolean operation tools. Those are add, remove, intersect, union trim, removing lump, and the assembly. So let's start with Boolean operation add. This command merges two bodies in with other. In Boolean operation add, this will merge two different body to create one body. Like, let's go to this file, and here we have part body and part body 2. So in part body, how to work on part body? Click on the part body, then right click in the context menu, define in work object. Now we can work on the part body and click on the any plane. Here I am selecting XY plane and then sketch, create a rectangle here. I will go with the center rectangle, then give the dimensions. This 100 mm and this length is 70 mm. Okay, then click on exit and give the height as 20 mm. Okay, now I would like to give the radius to all the edges. For that, click on the edge fillet, click on these edges. Also, I want to give the radius to this face as well, and the radius will be 5 mm. Click on OK. Now I have a body created. Okay. Next, I will create another body which is already created here. Body 2, right click and define in work object. Click on the plane we want to create. Here I am clicking on this plane, XY plane again, and create a circle. This is of diameter 30 mm and exit workbench. Now I will go with drafted filleted pad. Here the length will be 50 mm and the limit I will select the XY plane and the angle should be 5 mm and OK. Now I have two different bodies. Here how body in part body, if we create in a single part, then if we hide any feature, then the whole body will be hidden. Here if I hide any body, it will not affect to the other bodies. If I hide this one, you can see only the body 2 is hidden. This body is not hidden. Even both are available on a single part, still both are act as two different body. Okay. So now how we will use the Boolean operation add. This command merge one body with another. How to use that one? Here what you will do, click on the body which will be added to the parent body. This will be the parent body. Now in the body 2, right click, go to the body to object and then add. Now you can see both the bodies are created one. Both, and here also you can find a add feature is added in the specification tree of part body. How you can use add Boolean operation add. And next one is the Boolean operation remove. Okay, what is Boolean operation remove? For that, what I will do, I will insert to another body, or I will just removing these ones, delete. You see, when I delete one body, still others are not removed. The add body is still here. You can now, and I will create another one. Part body look like this, and here this length is 100 mm, and these two lines are symmetry about vertical axis, and this length is 20 mm. This is also the same. Here these 2 points are also symmetry about this line, and this is 30 mm, and this total length will be 80 mm, 60. Yeah. Now click on the exit workbench, give the height. Here I will give it 30 mm. Okay. And I want to remove a pocket from here. We can use by using pocket tool, but we will go with the Boolean operation remove. For that, insert a new body. Okay. And in this body, I will need another plane which is of 10 mm offset. Okay. In this plane, I will click on this plane, click on the sketch. I will create another one. Like this. Then double click on the constraint, right click, click on one line, click on the another line, right click, allow symmetry line, this one. For this one as well, make it symmetry. Okay, done. This is of 70, and this is 5 mm. Same way, make it all over the same. Let's make it, and this is 20 mm. Yes. Make this 20 mm, this one as well. Okay, and this is coincide with this one. This is going outside, so it will 10 mm. Okay, this is not required. This is not 1, this is 10 mm. And I will create a line, vertical line here, horizontal line here, so on. this one coincidence, this one right click, line object, horizontal, and this point and this point coincidence. Now our sketch is fully constant. Also I will give some radius here. I will give it later, and give the height as 30 mm. Okay, done. Here what we will do, we'll give radius to these points, this one, okay, 5 mm. I will hide this one and then give this radius 20 mm. Okay. These two actual. And with this one also. Now another body is created which we will remove from the main body. Okay, what we will do, click on this object, the body 3 here, right click in the body 3 object, then remove. Now the same profile what we have created on body 3 is removed from the part body. In this way you can use Boolean operation remove in CATIA. Okay, next one, Boolean operation intersect. How to use the intersect in Boolean operation? Intersecting means intersecting two bodies result in a common material shaped by these bodies. Okay, intersection, you know, intersection means it will intersect two different bodies and create the common material shared by both the bodies. So what we will do, I am just deleting this one. Okay. Here I have a body called part body, and click on the XY plane. I will create a circle here. Give the diameter as 30 mm. Diameter is 30, and click on the exit workbench. Give the height. I will give it 30 mm, let's say, and insert another body. This will be body 4, and here click on the ZX plane here and create. I will create a elongated hole, a slot feature like this, and make it fully constant. This is 16, let's say 15 mm, and click on this one. This is 2 mm. I will increase this to 5 mm, and this length is 8 mm. Okay, here I have a sketch, fully constant sketch. Click on the exit workbench and use the add tool and mirror extend. The add will be 30 mm in length, and okay. Now I have two different bodies. You can see 1 and 2. Okay. Now I will use the intersect tool to create the intersection between these two bodies. For that, what we will do, click on the body 4, right click, body 4 object, and intersect. Now you can see the intersection is created with the common material shared between these two bodies. What is the common in between them? The circle, which is here you can see this is with radius created, and the this profile is inside the body. So this will create the intersection between both the body. This is called intersection in CATIA Boolean operation. Next one is the union trim. For that, here also I will delete both. In the part body, union operation trim. What is union trim? This command defines element to be kept or removed while performing union trim. Union operation. This will define which element you want to keep or which one you want to remove. For that, I will create click on the any plane you want to click. I will click on XYZ plane and click on the sketch tool. Here I will create a profile. A 3-point arc with limit. That's what I will do. First limit, the second limit, and the radius. These 2 points should be symmetry about this line. This is of length 100 mm, okay, and the this is height is 20 mm. Click on the exit workbench. This will work as a guide, okay, and I will create a profile here which will be another, okay, and these 2 symmetry about this line, okay, and this is also the same 20 mm, and from this to this, let's keep the radius. Here it is 5 mm, yes, 5 mm, and we can give the width actual. This is of 15 mm. For that, delete this one. Delete the radius. This will be like this, and keep this height as 18 mm. Okay. Now click on the exit workbench. We'll give some thickness here. So for that, what we will do, I will create an offset of this one. This is 1 mm, okay, and add these 2. This point, click on this point, coincidence, Close this. Now create another line, such here. Now my sketch is fully constant. Click on the exit workbench. I will use the rev command, and here is my profile, and the center curve will be this one. See, a profile is created. Okay. Next one, I will insert another body 5 here. Click on this tool, XY plane, and click on the sketch, and here I will create a circle. Okay, this circle, this is of diameter 10. Click on the exit workbench. Here also I will use the drafted filleted pad. Okay, this is length 30 here. Okay, make it 35, and the limit will be this one, the same plane and 5-degree angle. Now I have two body created. Okay, here I want to use the union trim operation. So what will happen? We will see it, or I will say make it height should be 30 mm. Let's make it. Okay, and fillet make it 1 mm. Now I have two body. So to use the union trim, click on the body 5, right click body 5 object and union trim. This will ask you, this is body 5 to trim, and with body part body, and this will ask for which face you want to remove, kept or remove. Like here, in the face, which one you want to remove, I will say this one. Okay, this is divided into 2, and which is also ask you faces to keep. So click on this one and this one. Now you can see these faces I want to keep, and this is I want to remove. So, and click on preview, you can see, and click on OK. This is called union trim. This will add the body as well as remove the face you want to remove, or you don't want to keep it on your design. This is called union trim. Next one is the removing lump. Till now we are using two different bodies to use the Boolean operation, but in removing lump, in only a single body, sometimes, like let's say, let's create a body, let's create an object part something. Let's say this is 10 mm. This is also symmetry about vertical axis. Make it 100 mm. This is 50 mm. This two, this is, let's say, 40 mm. This is 15 mm. The height is 80 mm. This is 10 mm. This one 40 mm. Okay. And also I have and this is 80 mm. This is of radius 15 and this radius is 10, and this line also coincide with this one. This is tangential with this one. These two, make this, delete this radius first. Now this is tangential with this one. Give the this length, this is 15 mm, and give the radius here 10 mm. Make it more, give it 20. Now click on the exit workbench and keep the thickness or height. Here it is 10, 20 mm. Okay. Here you can see sometimes this kind of object is created. Sometimes we let with this section which is not required. Okay. What we will do? Click on right click here, object, and here you can see the removing lump tool is available. This is called lump, which is a extra one which is not connected to anything within this body. So we will remove this one. For that, removing lump, click on this one, and here you can, this will ask for which faces you want to remove. Click on this face, click on the remove face to remove, click on this one, and click on faces to keep. Click on this one and click on this one. Now you can see the preview and OK. Now you can see the lump is removed from the object. This is called removing lump. Okay. Till now we will use the 5 different Boolean operations. Now we have another Boolean operation, it's called assembly. For that, delete. Now I have a body. I will create a, click on the XY plane, we will create a object here, a feature here we will apply, and this is 100 mm. This is 80 mm. Okay, click on the exit workbench, give the height 20 mm. Okay, now use the fillet, edge fillet. Here I will select these fillets, these edges to be fillet, and this face also to be fillet. This is of radius 5. Okay. Okay. Now I have body 1 is created. I will insert another body here. Okay. This body I will click on the XY plane again, click on the sketch. Here you can see a symbol, it's called plus in the body. Okay. In assembly, it indicates part specification. The difference between add and assembly command is that add joints in the part irrespective of the definition. Assembly integrates the component according to created definition. Means here you can see body is in plus. Okay. If I create a circle here, okay, and then give the diameter here, let it is 30 mm. Exit workbench. Here what I will do, I will create a pocket here. Okay, not simple pocket, let's make it more, and I want it drafted filleted pocket. Okay, click on the sketch, reverse the direction. I want it is 50 mm in depth and 5° in angle. The limit is the XY plane, the same plane it is created, and angle is 5°. And click on OK. We have here you can see in this body we have created the pocket. Still it is created as a pad. As you know, pocket is a remove material feature. Still it's add the material, but you can see in the body the plus symbol is changed to minus. Okay, this is how your definition is created. This is called created definition in body. Okay, here this is created. If I just click on this body, right click, body object, and say assemble, here you can see your desired result is created. Means when you create the body 6 as a negative or removed material feature you have created here, the pocket feature, so it will remove the body 2 from body part body, your part body 1. In the same way, if we say, I'm just undo it and define in work object, this sketch I will create a drafted filleted pad. Everything is same, 30 length is 30, this is this one, length is 50 previous case, so I will make it 50 and OK. Now still we have the same feature here also, but this is in plus in the body. So if I do the same assemble, then you can see this is add the material to this one. When I create the pocket, this will remove the material from the body, and when I use the pad, then this is add the material to the part body. This is called assembly in Boolean operation in CATIA. In this way you can use different types of Boolean operation in CATIA. Now we have this one left with us, which we we will want to create the final output of this one. For that, what we will do, we have four different body. This one is the main body. I will click on the body 4 and I will just this one and remove from body and after shaft. You have seen this is created. Again, I have left with body 3. I will do the same, body remove and OK. And at last the body 2 and remove. Here you can see my final output is created by using Boolean operations. So what is the tree structure and the best practices? Always remember, activate the correct body before creating a feature. If you want, it is always to define the work object in a body to work in your desired body. Sometimes some people doesn't make it the defined work object and start working. That means the default working object will be selected and your sketch will be go there. That time it will ask for your body is not in this, your sketch or feature is not in this body. That time you have to remember that you have to select the define work object. Rename the body clearly. Here we have in example, that's why we didn't rename these bodies. You have to rename these bodies clearly for your understanding and better design intent. Keep Boolean operation at the end of the tree. Okay. Always create all the feature first, then at the last you use the Boolean operation. Follow design intent, not just geometry. Follow the design intent, not just only the geometry. Industrial applications. Multibody and Boolean operation is heavily used in automotive components, plastic parts, castings, tool and die design, sheet metal tooling. So that's all for today's tutorial on multibody method and Boolean operation in CATIA V5. If you found this video helpful, like, share and subscribe to Enginuity Lab for more CATIA V5 and GD&T and mechanical design tutorials. Thank you for watching Enginuity Lab. See you in next part.